Okay, student, we are back. So now we're looking at the active mode, which is the mode in which the transistor behaves like an amplifier. Amplifier, and that's what we're gonna have to discover. As we've said, in the active mode, the EBJ junction is forward biased, and the CBJ junction is reverse biased. Okay, so for us to identify how it behaves like an amplifier, and now we are moving on to the small signal slides, basically, if I refer to the slides. And by moving to the small signal slides, you'll see the very first slide shows how a BJT, when operated in active mode, ends up amplifying a signal. But the underlying principle here is that in active mode, the BJT can be thought of as a black box, to which when when a certain VBE is applied, which is greater than the barrier voltage of, and here VB is the barrier voltage, not confused with VB, which is the base voltage I just referred to now. Here I'm referring to the barrier voltage of a silicon diode, which is 0.7 volt. So when it's greater or equal to 0.7 volt, meaning we are talking about the EBJ junction being forward biased, meaning VBE must be greater or equal to 0.7 volt. We theoretically consider that, although in reality, after about 0.4 volts of VBE, the EBJ junctions becomes already forward biased. But for theoretical consideration, we will work with 0.7. So when a VBE is applied to a transistor in the that forward biases its EBJ junction, there is a collector current that is generated on the output. So naturally, a transistor, when operated in active mode, meaning with the EBJ junction being forward bias, meaning VBE applied across it, or VEB if it's a PNP, being a voltage higher or equal to 0.7 volt, while the CBJ junction is reverse biased, uh, naturally a transistor generates a collector current. So naturally a transistor is actually the type of system to which you would apply voltage on the input, voltage in, and you'll get current out. So the output being a current and the input being a voltage, it is naturally a transistor when operated in active mode is naturally a transconductance amplifier. Transconductance amplifier. Transconductance comes from the fact that the input is voltage, the output is current. Current, voltage. A system to which you apply voltage and get current is a transconductance amplifier. And why amplifier? Because we are applying a small VBE, as you can see, about 0.7 volt, in order to get a much bigger IC collector current. So I'll spare you the physics, although we did this in class when we were still having contact. There is a lot of physics that defines how is this output current of a transistor operated in active mode related to the VBE. But in short, it lands on an equation that says that the collector current you get out of a transistor used in active mode when applying a certain VBE, which forward biases it, is related to that base voltage by the following equation: IS multiplied by e to the VBE over VT. Let me define all the different terms. IS is the saturation current, but now I'm not talking about the saturation collector current or saturation base current. Here I'm talking about an intrinsic composition based saturation current, which has to do with the number of the density of electrons and the density of holes in the transistor. So it's very characteristic of its nature, and this is normally given in the data sheet. So you get that from the data sheet. And if it's a problem we're asking you, will normally give you IS. Now, the other parameters VBE that you are familiar with, and we have VT. What is VT? This is thermal voltage. Once more in electronics 1, you must have touched on thermal voltage. And you define thermal voltage as the little voltage variation that happens in a transistor or in a diode, in a semiconductor in general, with a junction, PN or NP junction, due to temperature. So that's the parameter that captures the influence of temperature on how much collector current you get out of a transistor by applying on its input a certain VBE that forward biases its EBJ junction, meaning when you're in active mode. And this is defined as the K multiplied by K, which is the Boltzmann constant, multiplied by, let's just recall here, it's going to be K multiplied, let me just confirm this, the Boltzmann constant multiplied by